Four-tube television camera. The four-tube television camera, intended for color television studio use, was first developed by RCA in the early 1960s. 96 in this camera, in addition to the usual complement of three tubes for the red, green, and blue images, a fourth tube was included to provide luminance black and white detail of a scene. With such a camera, a sharp black and white picture was always assured, as it was not necessary to combine signals from the three color tubes to provide the luminance detail. In the early days of color television, from the mid-1950s to the early 1960s, studio cameras were heavy and hot running because of the vacuum tube thermionic valve circuitry. With these cameras, there was always a tendency for the three colored images to drift out of registration over time, giving a consequential loss of picture sharpness. In 1962, in order to address these stability problems, RCA announced their prototype four-tube camera. The aims of the designers of the camera were firstly, to produce a camera that was more tolerant to misregistration, and secondly, to achieve a lighter camera by using smaller Vidicon tubes to replace some of the large heavy I/O tubes. The camera had an image orthicon tube for the luminance channel and three Vidicon tubes for the color channels. In addition, the camera was fully transistorized, apart from the four pickup tubes. The camera went into full production in 1963, and sales of several hundred of the model were achieved over the next few years. In the mid-1960s, following RCA lead, other versions of the four-tube cameras were produced. See below for details. In many cases, advantage was taken of a newly available pickup tube, the Plumbicon. This new tube allowed cameras to be smaller and lighter than before. However, by the end of the decade, four-tube cameras had fallen out of favor with most manufacturers and customers. The picture quality and stability of pictures from three-tube cameras had improved markedly, thanks to solid-state circuitry, improvements in the Plumbicon tubes, and the use of picture enhancement techniques. In addition, three-tube cameras were smaller, lighter, and cheaper than the four-tube versions. By the early 1970s, only a very few manufacturers still made cameras using the four-tube format. Advantages of the four-tube configuration. In a three-tube color camera, the luminance black and white signal is derived from a combination of the three color signals, so severe demands are placed on the registration accuracy of the three images if sharp pictures are to be achieved. With a four-tube camera, however, this registration problem is avoided because the transient edges in the luminance signal all originate from a single tube. Although achieving sharp pictures had always been a desirable aim, it was of particular concern in the early days of color television, when the majority of viewers still had black and white sets. It was considered essential that these viewers should see no degradation in picture quality when viewing color transmissions. In addition to allowing the registration accuracy between the color images to be relaxed, the four-tube camera allows additional misregistration of these three images relative to the luminance image. This is because the presence of a sharp black and white image allows significant displacement of the color content to be tolerated by the viewer, a feature long exploited by the publishers of cheap color comics and magazines. RCA engineers in 1964 considered that registration tolerances could be relaxed by 3 times relative to a three-tube camera. A later study by the BBC comparing three- and four-tube arrangements concluded that tolerances could be relaxed by at least 2:1 in the four-tube case. A further advantage of the four-tube system concerned noise in the picture. As the composite signals in NTSC, PAL, and second systems all used band-limited color information, so the color channels in a four-tube camera could be band-limited appropriately. This ensured that there was no contamination of the luminance picture by high-frequency noise from those channels. Disadvantages of a four-tube system were increased costs, a larger and heavier camera, and reduced light levels when the color tube's light was stolen by the luminance tube, making such a camera less suitable for outside broadcasts in low ambient lighting. An alternative way of producing a sharp luminance image was the three-tube luminance, red-blue camera, the YRB camera. However, this system was not favored by most manufacturers because it was deficient in color hue fidelity. A 473 even so, a three-tube camera of this type was produced by Bosch/Fernseh, their type KCU40. Historical background: early three-tube cameras. Up to 1962, television studios used three-tube image orthicon cameras for programs in color. For example, RCA offered the TK-41G, the PC-15, and PC-25, Marconi the B848/B3200. They were all big, heavy cameras. For example, the TK-41 with zoom lens was 5 ft long and it weighed 500 pounds. However, when properly set up, these image orthicon cameras could give pleasing pictures, which had the sharp, crisp look that was a characteristic of the I/O pickup tubes. See video camera tube image orthicon. The first four-tube camera, MRA. In March 1962, RCA demonstrated the first four-tube camera, the TK-42XX for experimental, which incorporated a 4.5 image orthicon tube as the luminance tube, together with 3 vidicon tubes to provide the color information. 96. This new camera had a conventional box-shaped housing, but it was lighter and shorter and had a 5:1 zoom lens integrated within it. The following year, with various technical issues resolved, the camera went into production. It now had a profile similar to the TK-41, but was considerably lighter and shorter. British four-tube cameras. In 1963, engineers from Marconi and EMI visited RCA in order to inspect this new concept camera. BBC engineers also visited RCA with a view to using the camera in the forthcoming UK color service. Following their visit, EMI quickly made an experimental four-tube camera by cobbling together parts from an EMI Type 203 image orthicon studio camera with parts from an EMI Type 204 vidicon industry. It produced sharp pictures, as expected, but there were problems with colorimetry. Pictures of this camera can be found on various websites. It is not a pretty camera. Pretty camera. Pretty camera. 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 A production version of this camera, the EMI 2000, contained a similar complement of pickup tubes, but was never built. Marconi, following their visit to RCA, also promptly set about the development of a new four-tube camera, similar in concept to the RCA-1. However, this work was soon abandoned in favor of an all-Plumbicon camera, the Mark Roman 7 camera. The camera was completed in 9 months and was the first all-Plumbicon four-tube camera to be available worldwide. It was marketed in the US from February 1966 and achieved substantial sales there. 111 lagging behind by over a year, EMI completed and demonstrated their Type 2000 four-tube Plumbicon camera. This camera was ready only just in time for the launch of the color television service by the BBC, but then proved to be very popular in Britain, with cameras installed in most studios nationwide. However, its late arrival, compounded by all the early sales going into the British market, resulted in the camera missing out on sales opportunities in the USA when, in the mid-1960s, a rapid expansion of the market took place. Furthermore, it made little impact in European markets, which were either not ready or already dominated by Philips three-tube cameras. Other developments. Following on from the TK-42, RCA produced several more cameras with a similar format. The TK-43 was a version of the TK-42, but with an external lens. The TK-44 had an isocon tube in the luminance channel and 3 plumbicons for the color channels. 116. The isocon tube was more sensitive than the image orthicon, so enabling the camera to operate at very low light levels. In outside broadcast use, however, it was a short-lived tube. 119. There was also a version of the TK-42 in which selenican tubes replaced the vidicons. None of these cameras sold in anything like the quantities of the TK-42. RCA also produced a 4-vidicon film camera, the TK-27. The advent of the plumbicon tube brought about the end for the image orthicon type tubes, 124, and from the middle of the 1960s onwards, virtually all television cameras contained plumbicons, regardless of the number of tubes used in a camera. This tube had first been announced 10 years previously, initially for medical use, 61, but much time and effort had been invested in making it suitable for broadcast TV use. GE ceased production of its 3XIO, the Type PC-25, in 1966. Meanwhile, the company had brought out, in 1965, a 4-tube vidicon camera, the GP-24, for film scanner use. This was followed by an all-plumbicon 4-tube camera, the Type P-150, which used conventional relay optics, rather than the prism optics of some other color cameras. This camera was later followed by the PF350 and PF400, which continued to use the 4-tube format. GE maintained, at that time, that 4-tube cameras gave the best pictures, 124. Philips Research Lab, a following RCA lead, also contemplated the construction of a 4-tube camera. Their new camera was to include an experimental 2-plumbicon tube, which was being developed for use in the luminance channel of this camera. The work was discontinued. A Russian camera, the Type KT-166M, used 4 plumbicons and prism optics. Demise. The 4-tube concept was developed in 1962, but the benefits it offered were not accepted by everyone. Even in 1967, at the Montreux TV Symposium, the pros and cons of the 3- and 4-tube system were still being hotly debated. However, by the end of the decade, 4-tube cameras were out of fashion. A 124 combination of high-quality plumbicon tubes, improved registration techniques, and electronic picture enhancement methods, 123 made the pictures from the 3-tube cameras completely acceptable, while 4-tube cameras were perceived to be big, heavy, and expensive to run. Such an outcome had been predicted by BBC engineers. RCA ceased production of the TK-42 in 1966, and by 1968 was offering the TK-44, 03 plumbicon. Philips continued to improve their Norco cameras, now offering their 3rd-generation camera. Other suppliers of 3-tube cameras were Ampex with the BC-230, 133 Visual Electronics, 125 in the US, and the Bosch Fernseh KCU40 in Germany. Only a few manufacturers continued with the 4-tube concept beyond the end of the decade. GE continued with the 4-tube configuration, next bringing out the PF350, followed later by the PF400, as mentioned earlier. For a while, Thomson CSF in France offered the 4-tube T2001, a camera that was basically the EMI 2001, but by the early 1970s was offering the 3-tube TTV 1515 initially. EMI continued the 4-tube concept by producing a 4-tube film camera, the EMI 2002, but this venture was not successful. The camera was almost as big and heavy as the 4-tube design on which it was based, whereas the competition now had smaller, lighter, purpose-built 3-tube designs. After that, EMI abandoned the 4-tube concept completely and in 1970 introduced the Type 2005. This was a conventional 3-tube design, somewhat similar in appearance to the 2001, but with an external zoom lens. It achieved modest sales in the UK. Color processing. There are 3 components in the composite waveforms for the NTSC. PAL and SECAM broadcast television systems: a wideband luminance signal Y and 2 narrow-band color difference signals containing RY and BY. These components are combined to give a waveform suitable for transmission. After reception and demodulation, the composite waveform is decoded to give red, green and blue signals which are applied to the three guns of a display tube. The luminance signal used in this process was assumed to originate from a combination of signals from the red, green, and blue images in a three-tube camera, where Y is given by here ignoring issues with gamma correction. For simplicity, Y equals 0.30 x r plus 0.59 x g e plus 0.11 x b e backslash display style y equals 0.30 backslash times r plus 0.59 backslash times g plus 0.11 backslash times b. And the processing in a color receiver assumes that the luminance signal has this form when the decoding of the composite signal into the individual color components takes place. The spectral scenitivity of the red, green, and blue channels had predefined characteristics, 478, which were achieved, in practice, by a combination of the characteristics of dichroic reflection surfaces, the optical filters ahead of the pickup tubes, and see the spectral characteristics of the pickup tubes. In the case of a four-tube camera, there is a problem with colorimetry if the signal from the luminance tube is used in unmodified form to represent Y, because that signal is likely to be panchromatic rather than having a characteristic similar to the luminance signal given by the equation above. Consequently, if the color difference signals use this unmodified version of Y, the decoded color display in the receiver will have saturation and hue errors. The various manufacturers of four-tube cameras used different methods to resolve this problem. RCA in their TK-42 placed an optical filter in front of the luminance tube which transmitted light according to the required luminosity function. Marconi in the MK-7 used a dichroic mirror to reflect light to the luminance tube, which had the required luminosity function. ME in their 2001 camera formed a low-frequency luminance signal from the band-limited color channels according to three-tube practice. The wideband luminance signal was corrected by this so as to achieve the required luminance characteristic at low frequencies. This process was referred to as the delta L correction method. In the G4 tube cameras, a neutral splitting prism with a semi-silvered surface was used to provide the image for the luminance tube, so no spectral shaping was used in the luminance channel. Instead, the cameras possessed an 8-position filter wheel located just after the zoom lens, so that a filter could be chosen to give optimum colorimetry in the TV picture according to the lighting conditions encountered in a scene. Camera data notes: some three-tube cameras are included for comparison. The all-up weight is given camera plus V/finder plus lens unless otherwise stated. The length normally excludes the lens. The table is incomplete. Abbreviations used: L equals length, W equals width, H equals height, VF equals viewfinder, ZM equals zoom, IO equals image orthicon, ISO equals isochron, vid equals vidicon, PL equals plumbicon, HAM equals camera, manuf equals manufacturer, RCA equals Radio Corporation of America, G equals General Electric Company, EMI equals Electrical and Musical Industries,